Assalamu alaikum friends. I'm Takdees Siddiqui with Computer Graphics for Bachelor's in Computer Science students, the course being offered by Virtual University, Government of Pakistan. Today is our 34th lecture. We have started our discussion about OpenGL programming. We have introduced ourselves to OpenGL, then we have used GLUT, and today we are going to continue with another sample program making use of some OpenGL functions. So, without any further delay, let's begin. We'll start with a sample program, as I said, and then this one is going to make use of OpenGL functions. The complete source code would be available to you in your notes, but we are going to explain different components of the program so that we get to understand how different functions work. This program that we are going to talk about today, at first sets the perspective projection matrix and then renders a triangle in the idle function. We have introduced ourselves to these very basic functions. We are going to make use of them more effectively today. GL matrix mode. This is the function that we are going to talk about first. And this function is used in order to set matrix mode. What different types of matrix modes are there? We are going to talk about them and we'll make use of each. GL matrix mode function specifies which matrix is the current matrix. We can have multiple. Which one is current? That is set by using GL matrix mode. And the syntax is void GL matrix mode, GL enumerated mode. GL enum is another type, and mode would be specifying the mode number. The matrix stack, that is the target of the resulting matrix operations, the mode parameter can have different values, and these include those that are appearing on your screens right now: GL model view, GL projection, and GL texture. GL model view applies subsequent matrix. So when you specify the next matrix to be specified, to be applied, to be made current, you make use of GL model view. GL projection applies subsequent matrix operations to the projection matrix stack. And the GL texture applies the subsequent matrix operations to the texture matrix stack. So these different values specified as the mode can be used with GL matrix mode function. GL matrix mode function sets the current matrix mode. The following function retrieves information related to the GL matrix mode, and this would be about the error codes that are returned and what they mean. So the error codes that we can encounter depending upon what error is made while programming the function, those include GL invalid enum and GL invalid operation. GL invalid enum is error code which is returned, which is set when mode was not an accepted value. When the mode value which we have specified with GL matrix mode function is not a valid value, then we are returned this error code, GL invalid enum. Whereas GL invalid operation would be returned if GL matrix mode was called between a call to GL begin and the corresponding call to GL end. Well, we'll talk about it later. GL begin and GL end pair can only allow specific set of instructions to be written between them. There are certain other instructions which, if specified between GL begin and GL end, they result in setting an error flag. We'll be looking at all those which are not allowed and then subsequently those that are allowed. So in between GL begin and end, there is a specific set of instructions which is valid one, which is permissible and should only be used. And if any other instruction is used between the two, then it results in an error code being returned. The next one is GL load identity. The syntax for it is void GL load identity void. No parameters are passed. The basic usage of this function is to load an identity matrix. This function replaces the current matrix with the identity matrix. It is semantically equivalent to calling GL load matrix with the identity matrix. So if we want, we can do it like using the GL matrix mode, GL load matrix. GL load matrix can be specified to load the identity matrix if it is specified as the matrix to be loaded, or we can make use of GL load identity as it is. This function automatically loads the identity matrix into the current matrix. Identity matrix you are already aware of, the one that has its main diagonal consisting of all ones and all other elements being all zeros. So GL load identity would load this kind of a matrix into the current one. And the error code conditions for this GL invalid operation, this error code would be returned when GL load identity was called between a call to GL begin and the corresponding call to GL end. So now we know that this is another function which should not be used in between GL begin and GL end. Otherwise, it is going to return an error. Next is a couple, GL translate D and GL translate F. The name suggests it is all about translation, the transformation that we talked about first when we started our discussion about transformations. GL translate D and GL translate F functions multiply the current matrix by a translation matrix. Void GL translate D, GL double X, GL double Y, GL double Z. So this would be the syntax for using GL translate D, and for GL translate F the syntax is void GL translate F, GL float X, GL float Y, GL float Z. We have seen how we have made use of the translation matrix when we were talking about transforming all matrix operations into uniform operations. We talked about translation, we talked about rotation, and we talked about scaling to start with. और फिर हमने देखा था कि scaling और rotation जो हैं वो तो as multiplication by default represent हो गई थी आसानी से, but ट्रांसलेशन का काम ऐसा था जिसके लिए हमें थोड़ा सा एडिशनल काम करना पड़ा था. ट्रांसलेशन में हम सिर्फ एडिशन करते हैं बिकॉज जो ट्रांसलेशन फैक्टर है एक्स के अलॉन्ग या वाई के अलॉन्ग या जी के अलॉन्ग उसको कॉरेस्पॉन्डिंग कोऑर्डिनेट में ऐड कर दिया जाता. इसे फिर हमने होमोजीनियस कोऑर्डिनेट्स के जरिए से इनकॉर्पोरेट किया था और तीनों ऑपरेशंस को एज मल्टीप्लिकेशन ऑफ मैट्रिसेस रिप्रेजेंट किया था. दैट होमोजीनिटी वाला जो आइडिया था दैट इज बीइंग एक्सप्लॉइटेड ओवर हियर, एंड ट्रांसलेशन इज ऑल्सो represented and implemented in the form of multiplication of matrices. So these two functions which make use of different types of arguments only, एक के अंदर double और दूसरे के अंदर float arguments इस्तेमाल हो रहे हैं, but otherwise they are the three x, y, z factors. So ultimately making use of these functions would multiply the current matrix with the translation matrix. GL translate function produces the translation specified by x, y, z. The translation vector is used to compute a 4x4 translation matrix. And you can see this is in accordance with what we have already discussed. Look at the rightmost column. X, y, z. These are those translation factors which would be used. And whatever our current matrix would be, that would get multiplied by this translation matrix with the translation factors x, y, and z over here. Just map it to whatever our discussion has been about the translation, where we specified these factors to be tx, ty, and tz, symbolizing for translation. The t was used. But the basic idea is that OpenGL has made use of the very same idea that we talked about in our theoretical discussion of translation. The current matrix is multiplied by translation matrix with the product replacing the current matrix. So multiplication का process जब complete हो जाता है तो उसके बाद जो resultant उसका आता है, that result is stored in the current matrix. It replaces the contents of the current matrix. So we have the translated matrix appearing after the operation. So if we have M as the matrix and T as the translation matrix, after this product, this multiplication, the resultant gets stored in M. If the matrix mode is either GL model view or GL projection, all objects drawn after GL translate are called translated. Whenever GL translate would be called in the GL model view mode or GL projection mode, then the subsequent objects would be translated. So any objects that would be drawn thereafter would be translated by the translation factors that were used while calling GL translate, whether D or F, regardless of it. Use GL push matrix and GL pop matrix to save and restore the untranslated coordinate system. Following is the error code and its condition for GL translate. GL invalid operation. This error code is returned if GL translate was called between a call to GL begin and the corresponding call to GL end. So yet another function which should not be called between GL begin and GL end. If you can recall, in our last sample program, we made use of these two and we had something specific written in between them. We are going to find out what are the valid functions that can be called in between GL begin and GL end pretty shortly. GLU perspective, GLU perspective. The GLU perspective is the function of GL utility library. This function sets up a perspective projection matrix. You would recall our discussion about perspective projection as opposed to parallel projection, in which we said that perspective projection gives us more realistic view as compared to parallel projection views. Void GLU perspective, GL double FOVY, field of vision Y, GL double aspect, the aspect ratio, GL double Z near, GL double Z far. I hope these would be ringing some bells in your minds. We have talked about these concepts. We are actually making use of them in this GLU or GLU perspective function. We are going to talk about each of these parameters or arguments individually. The first one is the field of view angle in degrees in the y direction. That is what GL double FOVY specifies. The second value is the aspect ratio that determines the field of view in the x direction. The aspect ratio is the ratio of width to the height. We have talked about the concept of aspect ratio. We can specify it over here. Whatever viewport we might be defining to be used, if that has appropriate aspect ratio, it is capable of displaying objects in a reasonable, in a viewable, understandable manner. Aspect ratios typically that we have talked about that are used in reality, like 4:3, those, if they are maintained, they give our views a more realistic look. The distance from the viewer to the near clipping plane, which is always positive, and that is specified by the Z near. In order to make sense out of this discussion, please recall our discussion about the viewing frustum when we were talking about the near and the far planes. That's what we are specifying over here. The distance from the viewer to the far clipping plane, which is always positive, that is given by Z far. So, making use of this very function, we can not only set or change different aspect ratio values, but we can also specify the viewing frustum. किस एरिया में अपीयर होने वाले ऑब्जेक्ट को हमने डिस्प्ले होने देना है और उसकी बाउंड्री से बियॉन्ड चले जाने वाले को हमने डिस्प्ले नहीं होने देना, ये भी हम यहाँ पर बता सकते हैं. सो अगर आप व्यूइंग फ्रस्टम बड़ा कर देते हैं, नेचुरली उस बड़े एरिया के अंदर होने वाली तमाम ट्रांसफॉर्मेशंस जो ऑब्जेक्ट की हैं वो व्यूएबल रहेंगी. और अगर व्यूइंग फ्रस्टम को आप छोटा कर देते हैं, यानी जी नियर और जी फार जो हैं वो एक दूसरे के करीब करीब आ जाते हैं, व्यूइंग फ्रस्टम छोटा हो जाता है, देन only the objects appearing in that area would be visible and others would not be. You can actually go and tamper with this sample program and play with these values to set different perspective, and you will be able to see the impact when you execute the program. The glue perspective function specifies a viewing frustum into the word coordinate system. In general, the aspect ratio in glue perspective should match the aspect ratio of the associated viewport. If we have a mismatch, then naturally we are not going to have expected results out of it. In order to have a view which would be anticipated, we better keep the two aspect ratios the same. For example, aspect is equal to 2.0 means the viewer's angle of view is twice as wide in X as it is in Y. If the viewport is twice as wide as it is tall, it displays the image without distortion. So this needs to be kept in mind, that if we are going to play with this aspect ratio, we are going to end up having different output. The viewport, if it is twice as wide as it is tall, अगर उसकी width जो है double है उसकी height से, then keeping aspect ratio 2 would mean that we are making the two aspect ratios coincide with each other, and we are going to have a acceptable result without distortion. The matrix generated by glue perspective is multiplied by the current matrix, just as if GL mult matrix were called. To load the perspective matrix onto the current matrix stack, instead precede the call to glue perspective with a call to GL load identity. So typically when we call GLU or glue perspective, it is the matrix that it generates, glue perspective, is multiplied by the current matrix, whichever it may be. Like when we call GL translate, it multiplies the translation matrix with the current matrix. Similarly, when we call glue perspective, the matrix generated by this function is multiplied by the current matrix, as if we had explicitly called GL mult matrix, which is used to multiply the matrices together. And in order to load the perspective matrix onto the current matrix without multiplying, if you want the current matrix that you have generated using the glue perspective function to be loaded onto the stack, then precede this call to glue perspective matrix with GL load identity. If you say that, what happens is that whatever the default function of glue perspective is, that is carried out. मल्टीप्लिकेशन होती है, लेकिन वो मल्टीप्लिकेशन चूंकि आइडेंटिटी मैट्रिक्स से हो रही होती है, बिकॉज मोस्ट रिसेंटली जो हमने लोड किया होता है वो आइडेंटिटी मैट्रिक्स होता है, तो रिजल्टेंट जो है वो वही ओरिजिनल पर्सपेक्टिव मैट्रिक्स ही रहता है जो ग्लू पर्सपेक्टिव की मदद से जनरेट होता है. GL rotate D and GL rotate F. Now these two functions are all about the rotation. The way we talked about translation, the same is going to go for rotation. Rotate बेसिक कॉन्सेप्ट्स जो रोटेशन के हमने पढ़ रखे हैं 2D और उसके बाद फिर उनको रीइंफोर्स किया 3 डायमेंशनल स्पेस के अंदर 3D कोऑर्डिनेट सिस्टम के अंदर, उनको जहन में रखिए एंड यू विल बी एबल टू मेक सेंस आउट ऑफ द फंक्शंस एंड देयर ऑपरेशंस. These are going to be used in order to rotate objects around. The GL rotate D and GL rotate F functions multiply the current matrix by a rotation matrix. Translate D और translate F जो हैं वो ट्रांसलेशन मैट्रिक्स से मल्टीप्लाई करते हैं करंट मैट्रिक्स को, एंड रोटेट D and rotate F would be multiplying the current matrix by the rotation matrix. Please recall that we have already learned how to express all transformations in the form of multiplication of matrices. The syntax for this, void GL rotate D, the arguments would be GL double angle, GL double X, GL double Y, and GL double Z. Void GL rotate F would use arguments GL float angle, GL float X, GL float Y, and GL float Z. So the angle at which you want to float, at which you want to rotate the object, that is given by the angle argument. In case of GL rotate D, it is specified as a double, and in case of GL rotate F, it is specified as a float. The GL rotate function computes a matrix that performs a counterclockwise rotation of angle degrees about the vector from the origin through the point. When you call this function, you specify an angle and you specify x, y, z coordinates. So the angle is the angle of rotation, which is used as the angle of rotation in counterclockwise or anti-clockwise direction, and the axis that is used for rotation is actually the vector which is defined by the line that is passing through the origin and the point specified using x, y, and z coordinates. So the x, y, z coordinates that we specify, that would be for a specific point. If we run a vector from origin to that point, a vector that runs through the origin as well as that point, that would become our axis of rotation, and the object, basically over here the matrix, that would be multiplied by the rotation matrix that would make use of theta, and theta would be the angle specified, and rotation would take place around this arbitrary axis, which would be defined by the vector passing through the origin and the specified point. And you can recall when we were actually discussing rotation, we talked about making this happen, making a rotation around an arbitrary axis happen in multiple steps. You could recall that we said that if there is some arbitrary line or vector which we want to use as the reference for our rotation, we want to rotate our object about that line or about that axis, then what we'll have to do is that we'll have to coincide that axis with one of the coordinate axes, x, y, or z, and then perform rotation about that very axis with which we coincide it. तो अगर हमारे पास इस किस्म का एक arbitrary vector आ गया जो कि origin से pass कर रहा है, तो we'll have to rotate it first to coincide with either x, y, or z, and then perform the rotation on the specified with the specified angle around that very axis, and then get back. All this is automatically done, is built in, making use of the GL rotate function. The current matrix is multiplied by rotation matrix with the product replacing the current matrix. Just the way it happens in translation, कि जो हमारा current matrix है उसको जब हम translation matrix से multiply करते हैं तो resultant जो बनता है वो current matrix की जगह ले लेता है. बिल्कुल उसी तरह से जब आप rotation के लिए multiplication करेंगे तो rotation matrix से multiplication के बाद जो resultant matrix बनेगा, that would take place of the current matrix, that would replace the current matrix. So after the product, if M was the original matrix, R was the rotation matrix, so after the product, resultant would be stored in M. Now about the error codes while using GL rotate. GL invalid operation. This error code would be returned if GL rotate was called between a call to the GL begin and the corresponding call to GL end. Another function which is prohibited to be used in between a GL begin and corresponding GL end. GL clear color. The name is self-explanatory, a function that would be used to clear the color. But how? The GL clear color function specifies clear values for the color buffers. We have multiple buffers, and GL clear color would specify values that can be used to clear the color buffers. Void GL clear color, GL clamp F red, GL clamp F green, GL clamp F blue, GL clamp F alpha. So in its totality, we are going to have these four values specified as arguments for the function void GL clear color, the RGB red, green, and blue, and the alpha. The GL clear color function specifies the red, green, blue, and alpha values used by GL clear to clear the color buffers. Values specified by GL clear color are clamped to the range 0 to 1, and we have already talked about the reason behind clamping them between these ranges, so that we can have our resultant as viewable colors that are generated. And for the error codes that can get generated while using this GL clear color, GL invalid operation. Error code is returned if GL clear color was called between a call to GL begin and the corresponding call to GL end. So we have added another one to the list of prohibited ones. Those functions that cannot be called between GL begin and GL end, the corresponding GL end. The next one is GL color. There are a variety of color functions. Some of them are given in your text. Some of them we are going to discuss over here. Complete list you will be able to find in your notes. GL color 3B, GL color 3D, GL color 3F, GL color 3I, GL color 3S, GL color 3UB, GL color 3UI, GL color 3US, GL color 4B, GL color 4D are a few to name. Look at the syntax for GL color 3B. Void GL color 3B, GL byte red, GL byte green, GL byte blue. And now you can make sense out of it that why the name contains the number 3 in here. GL color 3B is for specifying the RGB colors, and these are specified as a byte each. We make use of 1 byte to hold the value for red, for green, and for blue. Mind you, these are signed bytes. Void GL color 3F. Look at the arguments. GL float red, GL float green, GL float blue. And this is where we will be specifying the red, green, and blue values as floating point numbers. And you can guess what would be the range. A new alpha value for the current color that can be added, and that can be included only in 4-argument GL color 4 function. So the range of functions that involve this number 4 in there, those would be accommodating this 4th value, and we already know what is the use of this alpha channel or the 4th component whenever we are playing with RGBA. OpenGL stores both a current single-valued color index and a current 4-valued RGBA color. The GL color function sets a new 4-valued RGBA color. So whenever we have to set RGBA color, 4-valued RGBA color, we make use of GL color function. There are 2 major variants of GL color 3 and GL color 4. And as we have already discussed, the significance of the numbers 3 and 4 in there. The GL color 3B, GL color 4B, GL color 3S, GL color 4S, GL color 3I, and GL color 4I. These functions take 3 or 4 signed byte, short or long integers as arguments. And when you append V to the name, the color functions can take a pointer to an array of such values. So we can also specify, we can not only specify the values itself that need to be used as the arguments, as the color values for R, G, B, and A, but we can also specify an array of such values that can be used automatically from that array by the functions. Current color values stored in floating point format with unspecified mantissa and exponent sizes. Unsigned integer color components are linearly mapped to the floating point values such that the largest value maps to 1.0 and 0 maps to 0.0. If we have any lower value, that would also be clamped to 0.0 whenever we are making use of the clamp idea. Signed integer color components are linearly mapped to floating point values such that the most positive values map to 1.0 and the most negative values map to 0.0. Now, it is important to note that the value clamping process does not take place before the operation is carried out. So originally, when we perform this operation, the values would be returned the way they are calculated, and the clamping process would be done thereafter. Neither the floating point nor the signed integer values are clamped to the range 0 to 1 before updating the current color. So the current color value gets updated, and only then the values get clamped to the range 0 to 1. However, components, the color components, are clamped to this range before interpolation, because this is the time when we require the colors to be in this valid range, because the colors that would be outside this range would not be correctly interpolated. So वो process जो हमने मुख्तलिफ तरह की शेडिंग के कॉन्सेप्ट्स में पढ़ा था, जिसके अंदर हम कलर वैल्यूज़ की इंटरपोलेशन करते हैं, भले वो गोराव शेडिंग की बात हो रही हो या अदर वेरिएशंस की, जिसके अंदर हमें कलर वैल्यूज़ की ज़रूरत होती है in order to be able to calculate all different shades of colors in between those two pixel values or those two vertices. उसके लिए हमें कलर वैल्यूज़ को 0 to 1 की रेंज में क्लैम्प्ड हुआ होना ज़रूरी होता है. सो इससे पहले कि हमारी इंटरपोलेशन का प्रोसेस स्टार्ट हो सके, these values have to be in the range 0 to 1, and they are put or clamped in the range 0 to 1 accordingly before interpolation starts. You can update the current color at any time. In particular, you can call GL color between a call to GL begin and the corresponding call to GL end. Nice to know. We have come across a function which is a valid, legitimate function to be used between GL begin and GL end pair. So, किसी भी GL begin के बाद corresponding GL end से पहले भी हम GL color को कॉल कर सकते हैं. So, effectively, color set करने या change करने के लिए we can use this function virtually at any time. So, there is no specific requirement that it must not be used here or must not be used then or when. So, we will be able to make use of GL color function to set a different color value in between GL begin and GL end pair as well. The GL clear function clears buffers to preset values. Void GL clear, GL bit field mask. That's the argument that we pass, and you can guess what values can be specified over here. We can specify some masks that would be actually used for bitwise ORing, and those operators having been ORed bitwise would result in one singular argument that would be passed to GL clear function, and ultimately the bits that are set in that mask would be determining which buffers need to be cleared or set to their preset values. There are different masks that we can use, and we'll be talking about them shortly, but these bitwise OR operators of masks that indicate the buffers to be cleared, and they are specified according to this list. Look at this. The masks are written in the left side. In the right column we have the buffer to be cleared associated with that value. So if we specify the mask called GL color buffer bit, then this would be actually doing what? The buffer currently enabled for color writing, those would be cleared. So this is one of those masks that we can specify. We can specify each and every one of these. Those that would be specified would be effective, and those that would not be effective. So the buffers that need to be cleared, corresponding masks will be specified in here for bitwise ORing to generate the final argument or parameter value to be used by GL clear. GL depth buffer bit, this is associated with the depth buffer. So if specified, this is going to do what? Would enable clearing of the depth buffer. Similarly, GL accum buffer bit would be for accumulation buffer or accumulator. GL stencil buffer bit would be associated with the stencil buffer. So if all of these are specified, we actually would mean that GL clear should clear all these buffers. And if we miss out any, the one that is missed out would not be cleared, the associated buffer would not be cleared, and others would be. The GL clear function sets the bit plane area of the window to values previously selected by GL clear color, GL clear index, GL clear depth, GL clear stencil, and GL clear accum. So these are the values that need to be specified prior to making a call to GL clear function. If we have set these values and then we make a call to GL clear using whatever appropriate bit mask that we need to use, then the corresponding buffers would be cleared using the specified clear values. The color buffers would be cleared using GL clear color value, index would be cleared or using index value, or depth buffer would be cleared using GL clear depth value. Similarly, stencil would use GL clear stencil, and accumulator would use GL clear accumulator. So these values have to be specified prior to making a call to glclear. If we don't do that, then whatever values are there in these glclear color, glclear index, glclear depth, stencil, or accumulator would be used to clear the corresponding buffers. You can clear multiple color buffers simultaneously using glDraw buffer. glDraw buffer is a function which can be made use of to clear multiple color buffers at the same time using the glclear color value. The glclear function ignores the alpha function, blend function, logical operation, stenciling, texture mapping, and Z buffering. So these are that it does not clear, it does not touch them. It only clears all other buffers that we have talked about. So if we have some value specified for the blend function, that would not be affected by making use of the glclear. So glclear would not be hurting any of these specified, the logical functions, logical operations, stenciling information, texture mapping, or Z buffering. The glclear function takes a single argument or mask, that is the bitwise OR of several values indicating which buffer is to be cleared. As I said earlier, we have different bit masks. We can specify each and every one of those or any that we need. Those that are specified, they are ultimately bitwise ORed, and that bitwise ORing generates a single mask. That mask is passed on as the argument to glclear and is used accordingly. The bits that have been set, they indicate which buffers need to be cleared using glclear. And those bits that have not been set, those corresponding buffers do not get cleared. They are not touched by the glclear command. And if we specify such a mask that sets all the bits, then all buffers that can be cleared using glclear would be cleared. If a buffer is not present, a glclear call directed at that buffer has no effect. अगर एक बफर हमारे पास है ही नहीं, we are not making use of that buffer, और उसको क्लियर करने के लिए हम बिट मास्क प्रोवाइड कर देते हैं, bitwise operator दे देते हैं, the mask, in spite of having set the corresponding value, would not have any effect because the corresponding buffer would not be existing. The buffers that exist, those would be cleared. Those that do not exist, this command will not have any impact reference to those. Coming to the error code, GL invalid value, any bit other than the 4 defined bits was set in the mask, and that would mean that GL invalid value code would be raised or returned. The values that we have specified, they are associated with the buffers that we have talked about. Any other bits, if they are set, they should not be set, they should be preset to 0. And if they are set, that means this is calling for an error, and error code GL invalid value is returned. The flag is set for this error. GL invalid operation error code would be returned, or the flag would be set if GL clear was called between a call to GL begin and the corresponding call to GL end. So this is yet another command that should not be used in between GL begin and corresponding GL end pair. If we make use of this GL clear command in between GL begin and GL end, this is going to raise an error, GL invalid operation. Now we come to the GL begin and GL end. We have been talking about so many things that cannot be written in between GL begin and corresponding GL end pair. Now we will be talking about certain things that can appear in between the two, and we'll see what impact this is going to have. We have touched GL color, which is one which is valid to be used between a GL begin and corresponding GL end. The GL begin and GL end functions delimit the vertices of a primitive or a group of like primitives. Void, GL begin, GL enum, mode. So basically GL begin और GL end functions जो हैं, इन दोनों के दरमियान में ये actually boundaries बन जाते हैं for specifying that in between these two we have vertices which are related to a specific primitive, which can be a point, a line segment, or it could be a polygon, and In addition to that, we can also have such cases in which we have a group of like primitives which are bound or delimited by the GL begin and corresponding GL end pair. Vertices we are pretty much familiar with. किसी एक पॉइंट के हवाले से अगर हम बात कर रहे हैं तो हमने वर्टिसेस का कॉन्सेप्ट डिस्कस कर रखा है. अगर किसी लाइन सेगमेंट की बात कर रहे हैं तो नेचुरली वी वुड बी रिक्वायरिंग एंड पॉइंट्स. द इंफॉर्मेशन ऑफ दोज एंड पॉइंट्स वुड बी स्पेसिफाइड एज 2 वर्टिसेस. सिमिलरली अगर हम ट्राइंगल की बात कर रहे हैं तो हम 3 वर्टिसेस की बात कर रहे होंगे. अगर किसी क्वाड्रिलेटरल की बात कर रहे हैं तो वी हैव टू हैव 4 वर्टिसेस. अगर मल्टीपल ट्राइंगल्स हैं और उन सब का डेटा हमारे पास मल्टीपल वर्टिसेस की इंफॉर्मेशन की शक्ल में मौजूद है, उस सारे को भी हम डिलिमिट कर सकते हैं बिटवीन GL begin and GL end functions. GL end does not use any argument. Void GL end void. The following are the accepted symbolic constants and their meanings. GL points. GL points क्या हैं? They are naturally about the points that need to be stored, that need to be created. Treats each vertex as a single point. Vertex n defines point n. N points are drawn. If we've got n points specified using GL points, then we are going to have, when I say n points, capital N points I mean, and small n is for any n, for any point n. So GL points treats each vertex as a single point. So if we have 10 vertices specified and we have GL points specified on top, that means that all these vertices are to be treated as points. So they would be treated as pixels that need to be displayed. GL lines treats each pair of vertices as an independent line segment. Vertices 2n minus 1 and 2n define line n. N by 2 lines are drawn if we have a total of capital N vertices. It makes sense. When we are talking about points, one vertex value is enough to specify a point. But whenever we are talking about line segments, we have to have 2. We have to have starting point and ending point of the line. So अगर हमारे पास लाइन सेगमेंट्स ड्रॉ करने हों इन्हीं वर्टिसेस की मदद से, तो हमारे पास क्या होना चाहिए? हर एक लाइन सेगमेंट के लिए 2 वर्टिसेस स्पेसिफाइड होने चाहिए. सो इसी तरह से GL लाइंस जो है वो एंटिसिपेट करता है कि हर 2 वर्टिसेस एक लाइन सेगमेंट को डिफाइन कर रहे होंगे. सो पहले 2 को इस्तेमाल करके एक लाइन सेगमेंट ड्रॉ किया जा सकता है, नेक्स्ट 2 को यूज करके नेक्स्ट लाइन सेगमेंट ड्रॉ सकता है, सो ऑन एंड सो फोर्थ. Whereas GL line strip draws a connected group of line segments from the first vertex to the last. Vertices n and n plus 1 define line n. N minus 1 lines are drawn. Just like triangle strips, we can have the concept of line strips as well. GL line strip draws a connected group of line segments from the first vertex to the last vertex. If we have n vertices specified, from the first one to the last we have multiple line segments defined, and GL line strip would take it to be first and second vertex values defining the first line segment, second and third defining the second segment, similarly third and fourth values defining the third segment, so on and so forth. So continuously जितनी भी vertices values given हैं वो हर next value जो है वो previous के साथ मिलके एक line segment बना देगी, और GL line strip would draw these line segments contiguously. GL line loop draws a connected group of line segments from the first vertex to the last and then back to the first. Vertices n and n plus 1 define line n. The last line, however, is defined by vertices n and 1. A total of n lines are drawn. जिस तरह से अभी हमने बात की कि लाइन स्ट्रिप की बात थी जिसमें कंसेक्यूटिवली हम लाइन सेगमेंट्स को ड्रॉ करते चले जाते हैं, GL लाइन लूप जो है वो फर्स्ट से स्टार्ट करके लाइन स्ट्रिप वाला काम करता चला जाता है जब तक कि वो nth तक नहीं पहुंच जाता. nth वर्टेक्स की वैल्यू जो है उसको यूज करता है देन फॉर लास्ट लाइन सेगमेंट स्टार्टिंग पॉइंट and makes use of the first vertex value, number 1 वाली, as the end point for that line segment, और total of n line segments draw कर देता. So इस तरीके से एक कंप्लीट लूप ऑफ लाइन सेगमेंट्स ड्रॉ हो जाता है, मेकिंग यूज ऑफ GL लाइन लूप. सो अगर हमने जो वर्टिसेस की वैल्यूज स्पेसिफाई कर रखी हैं वो n है, तो वी आर गोइंग टू हैव n लाइन सेगमेंट्स ड्रॉन. GL triangles treats each triplet of vertices as an independent triangle. Vertices 3n minus 2, 3n minus 1 and 3n define triangle number n. n by 3 triangles are drawn. जो GL पॉइंट्स के केस में है, हर वर्टेक्स एक पॉइंट के तौर पे लिया जा रहा है. GL लाइन के केस में हर दो वर्टिसेस मिलके एक लाइन सेगमेंट की रिक्वायरमेंट्स पूरी कर रहे हैं. सो वो एंटिसिपेट करता है कि दो जो वर्टिसेस की वैल्यूज हैं उनको यूज किया जाए और लाइन सेगमेंट डिफाइन किया जाए. जो GL ट्राइंगल्स हैं, दे एंटिसिपेट 3 vertex values to be specifying the 3 vertices of a triangle. So by default, when we make use of GL triangles, this is making use of every 3 vertices as the defining vertices for a triangle. पहले 3 लेके फर्स्ट, सेकंड और थर्ड उनके जरिए एक ट्राइंगल डिफाइन हो जाएगी, फोर्थ, फिफ्थ और सिक्स्थ के जरिए से एक हो जाएगी, एंड सो ऑन एंड सो फोर्थ. सो हर 3 वर्टिसेस मिलकर एक ट्राइंगल की डेफिनेशन कंप्लीट कर रहे होंगे for GL triangles. But we have seen other variations of triangles as well. We defined not only triangles, but we also defined some triangle fans and triangle strips. Those are also valid over here. The GL triangle strip draws a connected group of triangles. One triangle is defined for each vertex presented after the first 2 vertices. For odd n vertices, n, n plus 1 and n plus 2 define triangle number n. For even n, vertices n plus 1, n and n plus 2 define the triangle number n. A total of n minus 2 triangles are drawn. The basic idea is the very one that we have already discussed in our theory in triangle strips. When we were talking about tessellation and we were talking about dividing surfaces into triangles, we talked about different structures holding information about triangles. So triangle strips का जिक्र आया था. Identical information is mapped onto this GL triangle strip. To complete it, GL triangle fan is also there. So it draws a connected group of triangles. One triangle is defined for each vertex presented after the first 2 vertices. Vertices 1 and n plus 1 and n plus 2 define the triangle n, and a total of n minus 2 triangles are drawn. The basic idea of pinning the first vertex as the common amongst all triangles holds here in the GL triangle fan. Then in case of GL quads, it treats each group of 4 vertices as an independent quadrilateral. The vertices 4n minus 3, 4n minus 2, 4n minus 1 and 4n together define quadrilateral n. n by 4 quadrilaterals are drawn, and of course we are making use of 4 vertex values because it's a 4-cornered figure. GL quad strip accordingly makes use of the same idea to define strips of quads and makes use of consecutive vertex values to come up with the idea. GL polygon draws a single convex polygon, and vertices 1 through n define this polygon. Simple as that. All the vertices are known to be part of definition of a polygon, a single polygon. So no matter how many points you have specified, those all will be made use of to define a polygon by GL polygon. The GL begin and GL end functions delimit the vertices that define a primitive or a group of like primitives. As we've already said, you can use only a subset of OpenGL functions between GL begin and GL end. The functions that you can use include GL vertex, GL color, GL index, GL normal, GL material. And you can also use GL call list or GL call lists to execute display lists that include only the preceding functions. If any other OpenGL function is called between GL begin and GL end, the error flag is set and the function is ignored. That's about it, folks. We have a lot more information available in your notes, and you can go ahead and read about it and make use of it to understand more different functions of OpenGL. But I hope this discussion would be able to put you on the road to making use of OpenGL functions along the side. You have made use of GLUT in order to provide you with some basic structure that you can use to start drawing objects, and now you can start making use of some advanced OpenGL functions, and we have touched a few. We have talked about certain exceptions, certain error codes that are returned, and we have talked about certain valid functions that are allowed to be written between the GL begin and GL end pair, and certain other functions which are not allowed. And what are their usages? We have talked about them. I hope that this discussion will be able to prove worthy for your further exploration into OpenGL, but this is an exciting odyssey. Just set out on the road and find your way through. आज के लिए इजाज़त दीजिए. फ़ी अमान अल्लाह.